This is the description of the asset Elastic T in the context of Work Package 3.2 for cybersecurity for Europe. This asset can be used in the geolocation scenario to improve the security of the location data being processed. So trust execution environments, or TE as they're called, offer secure computation on potentially untrusted operating systems. And as such, they are particularly appealing for cloud-based applications because customers of the cloud can offload their computation with the guarantee that the code will execute as expected and with confidentiality guarantee for their data. Nevertheless, the deployment of these in the cloud, at least of current TEs, like for example in the SGX, require intervention of the TE owner, the party that wrote the application that it's supposed to run in the TE. And this is somehow, this clashes with the cloud operation that usually require dynamic resource allocation. The cloud should on the fly be able to add or remove resources to a particular application. So the asset that we call Elastic TE somehow provides an harmonization between the security of TE and the operational requirements of the cloud provider with respect to dynamic resource allocation. In particular, Elastic TE allow dynamic resource allocation for TEs without the intervention of the TE owner and with the same security guarantees of the underlying TE. To achieve this, we augment the cloud architecture with a tool that we call Replica TE. Replica TE is composed by two different services. One is called EML, Enclave Management Layer, and this is the layer that somehow helps the cloud whenever dynamic resource allocation is needed. And BSS of Byzantine Storage System is a Byzantine fault tolerant storage that is used by EML to always have a consistent view of the number of application instances that are running on the cloud. So this is how Replica TE works. We have an application owner that provides the application to the cloud provider, and the cloud provider will deploy this application based on needs on one of its TE-enabled machine. Now, whenever this happens, the application owner would need to be online. This is the current deployment model for TEs. What we do is that somehow we use a sort of proxy, this is the EML, that acts on behalf of the owner, so that the owner doesn't have to be online whenever a new application needs to be deployed on a machine. And when that happens, the EML assists the cloud provider in this deployment. And EML, as you see here, it's connected to BSS, and this is somehow to keep a consistent view of the applications that are running on a machine. We also built a prototype of Replica TE. Here we see two different configurations based on the number of faulty nodes that we could have in the BSS service. BSS is a distributed storage system, so it depends on the numbers of nodes that we have there. We might have different performances. And here what we see is latency versus throughput. So we basically increase the number of operations per second and the number of enclaves that we want to deploy each second, so the number of requests that EML should serve, and we observe the latency in deploying such application. And as we can see, our prototype of Replica TE can support without any problem up to 60-70 requests per second. Then the system starts saturating, and so the latency increases.